Hello guys, welcome to EasyMathWithDami. Today we're talking about the problem on the screen, which is e to the power of ax cos bx dx. So to solve this kind of problem, we have to note that it's a recursive integration, and then the reason it's recursive integration is because our function, which is e to the power of x or cos bx, if you take any one of them and then you integrate them or you differentiate them, uh, they don't go to zero, right? So if you integrate your exponential x 1000 times, you keep getting exponential x 1000 times. So this is what I'm trying to say. When I have something like this, e to the power of 2x, yeah? So e to the power of 2x and differentiate this, that's dy dx. So this is going to be 2 e to the power of 2x. And then if I take this guy again and then I differentiate this guy again, it's going to be 4 to the power of exponential e to x. So it goes like that and then it doesn't go to zero, right? So we keep getting back this exponential, you see. So this exponential keeps coming back. And then the same thing with your cos. So if you take your cos and then you differentiate your cos as well, you're going to get negative sine. And then if you differentiate your negative sine, you're going to have a negative cos. And then you see it's coming back again and again. So that's why it's called a recursive integration. So basically, we're going to apply the same method we know, right? This is the formula, right? So we're going to apply this to that, and then we get our answer. So the only difference is just that we're going to get back the integral, sorry, and then we can just do some like terms, and then we'll get our answers. So today, I will be solving this using the tabular method as well, and then the normal formula one. So the first thing I'm going to do is that I'm going to use the formula to solve it, and then subsequently, maybe I don't want to spend so much time on this, but if I'm not taking so much time on this, then I can uh add the tabular method to it. But if not, maybe the subsequent video I'll just make that one for the tabular method. So let's just dive in straight away. So I can just call this guy I, right? So we have I equal to integral of e to the power of ax cos bx dx here, and then we know how to choose our what our u is and then the v, right? Because we talked about that. So I can just say u is e to the power of ax, yeah, and then dv is what cos bx dx, yeah. Okay, so from here we just have to differentiate and then integrate and start everything back into the integral, yeah. So now we have du to be a ex dx, and then dv is gonna be 1 over b sine, sorry about that, this should be v, then sine bx. So if you're getting confused about the integration, maybe subsequent videos I can just do kind of like a review on integration. Maybe that could help. So let's just follow this through, and then I guess you're gonna get it straight. So du, okay, and then we have b, yeah. So now my I, which is my integral, becomes the uv minus integral, which is this, yeah. So my u is what? It's gonna be ex, yeah, dot the v, which is 1 over b sine bx, yeah, minus integral v, which is 1 over b sine bx, then du, which is a dx, yeah. So this is, so just to simplify, Okay, and then this is gonna be a over b. Okay, so that's it. So you can see now we have to integrate this guy again. Yeah. So to integrate that again, all you have to do just to make it simplified, make it simple so that it's not going to be complicated. So I can just call this guy I1. Yeah. So I call that I1. I call that I1. So then I have I to be EX B sine BX minus A over B I1. Yeah. So I can just call this asterisk. Yeah. So which implies I have to find what my I1 is and then slot it back in here and then I get my high and that's it. So now we take this I1 how? Yeah. So I1 which is integral e to the power of ax sine bx dx. So I have to do the same thing to this. I mean, it's just like what we've done in the past, so it's the same thing, not difficult. So I have my u to be this, yeah, and then I have my dv to be sine dx. So so that I have my du to be a, yeah, and then v to be negative 1 over b cos bx. Yeah. So then I can now say that my I1 applying the same thing to it, uv minus v du. Yeah. So I1. So let's just use this place. I have so I have I1 to be equal to uv. So the u is what? Exponential ax v, which is negative 1 over b cos bx. Yeah. Then minus integral v du. Yeah. So the v is negative 1 over b cos bx, and du is a, yeah. So my I1 becomes this. So basically we can see from the I1 now this integral here is the same thing as a high, yeah, which is our question from the beginning, yeah. So this is the I. So I can write my I1 to be this. Yeah, so this is I. That's it. So we can then now substitute the I1 back in the asterisk. So our I from asterisk, then our I becomes e to the power of ax over b sine bx minus a over b high, which is I1, sorry. So which is this? Which is this, yeah? So from asterisk, substitute in okay, so I think this should be okay, so you just substitute in double asterisk in asterisk, yeah. So we have our I to be this e to the power of x over b sine bx minus a over b. Then this is gonna be this plus, yeah, cool. So we have our I. So now we can just expand this guy. So we expand this. So we are going to expand that. So that's gonna be b squared ax cos bx, yeah. Then minus a squared over b squared high. So now you can just call it like terms, yeah. So just collect like terms. So when we collect like terms, so we're gonna have I plus a squared b squared high, yeah, and this is gonna be this, yeah. So you're just kind of like writing it again. So we can just go ahead and then add the terms together, take the LCM of this guy, that's gonna be sorry, so that's gonna be a squared plus b squared over b squared I, yeah, okay. And here our I, which is our integer, becomes b squared over a squared so it's gonna be that, yeah. So you could just go ahead and then simplify, or you could just leave it like that, whichever way it's beautiful. So our I becomes 1 over a squared plus b squared. So and this is gonna be b to the power of ax sine bx plus a e to the power of ax cos bx. Yeah, and that's it. So if you remember our I, which is this, yeah, our I, which is this, yeah, that's it. So it's the same thing. So which implies that we've gotten our answer, and that's the integration. So if you want to integrate exponential ex cos bx dx or anything that looks like this, you're going to go through the procedure of gone through, and because it's kind of like a recursive integration, and then you come to this answer. I know it looks you know, kind of difficult because it's recursive, but it's pretty easy once you know the formula and kind of like, you know, integrate it appropriately and then differentiate it appropriately. So you could just put in all the ingredient and then you make a good soup, and that's it. So maybe next video I'll be showing you how to use the tabular method to solve that, because that's a lot easier instead of going through this, you know, having to integrate over and over again. Just use the tabular method and then everything comes out the way you want it. So thank you guys for watching this video. Thank you so much. If you enjoyed this video, kindly like, share, and then subscribe. Thank you. See you on the next one. Bye.